Ah. I had an Italian exchange student in here. He's like, I don't get it. I'm like, it's a really bad part of American history. It's okay if you don't get it. We're not proud of it. Where did it go? Just checking. What's that? 0. Integrating something area under a dot? Nothing. How far did you travel in 0 seconds? You didn't. In 13, we talked about it a little yesterday. Arctan.
Did we do the double math?
Yeah, but we did this specific, like,
Yeah.
so this is the textbook stuff that I replaced with Delta. And that I don't, like, Delta has like, hey, random. I don't know if it got to all the pieces that I wanted it to show you. But I wanted to revisit this again. Tangent of what angle makes +1? And then tangent of what angle makes -1? First period told me 3 pi over 4, 7 pi over 4, and neither of those is right. It's not capitalized or anything, but it's implied to be the restricted, give the one and only answer that the calculator would give you. So that one's a pi over 2, ends up being. Did I change this yesterday and we did like infinity? No? Oh, all right. Foreshadowing chapter 8. Which we would never actually write infinities there. There's this whole big hoogity-booge to do about that. But what angle makes tangent infinity?
No.
Is tangent undefined anywhere?
Oh, it's
Here's what arctan looks like. What are them theirs?
pi over 2 or negative pi over 2?
So I can integrate this shape, not arctan, but that shape's area under the curve for all of time, negative infinity to positive infinity, and it comes out to be a finite number of pi. I thought it was this class, but I don't know. Some of you yesterday had said something like, but integrating symmetrically, it's going to be 0 because it's an even or odd function, same amount below, same amount above. I'm like, this is not the equation we integrated. It's this guy. The snake that ate lunch. That has finite area even though it goes forever. Okay. I needed to show you something new, something not super new, but something else. Okay. These words, total area. Let me look at something else first. So Felipe, looking at this, how I have it drawn, what is the integral from 0 to b?
-1.
-1. Because up area, stuff below the axis is negative. Sam, what would that be?
7.
Okay. Benji, what would that be? So it matters that the absolute value is inside versus outside. Inside, Sam was like, all right, that down bubble is an up bubble, ha. If I put it on the outside, it says, do the answer like regular, like Felipe did, and make it positive. Okay. There are some problems, and it's just wording, and I want to make sure that we're okay with it. If it says find the total area, do you think this counts as positive or does it count as negative?
Positive.
Positive. So total area is, I need to paint this space. It might be below the water line, but I need to paint the space. Do you need to use paint? Yes. So if it says total area, they mean all the stuff that's stuff. So to give like an analogy for that, it's you ran around the track, around. Your displacement when you came back was 0. You ended up at the starting line. Go you, woo! Your Fitbit, however, ran, and it's clocking, like, even if you're going forward or backwards, you moved around, you did 2 miles. Go you. So total distance, total area versus net or displacement. Okay? All right, so we'll try the question that is up. First one, find the integral. Just integrate. Down here, find the total area. Lily, what'd you get for the integral?
I got -3.
Lily, what did you get?
I got 3, but that
Oh, my bad.
Oh, like the integral, like the equation.
I meant the number, but you said you got 3?
Yeah.
Okay, let's. So just integrating, undoing power rule, raise the power, divide by the new power a couple of times. Plug in 3, 12 minus 9, minus 0, minus 0. I get 3. Okay. Total area without a calculator. Does this, if it's always positive, it doesn't make a difference. Is it always positive? No? When does it go negative?
It's negative after 2.
After 2. How do we find that? Well, it's not undefined anywhere, and if it's gonna change, it had to hit 0 at some point. So at plus or minus 2, but we want the positive region. So the graph is gonna look like that. So how do I answer part B? What's the process that I'm gonna have to do?
Integral 0 to 2, integral of 2 to 3.
Okay. We said integral 0 to 2.
Absolute value of both.
Well, calculus by hand, how do I do absolute value? I need to split it up into piecewise functions, which is what you're doing here. Okay, you said, what's the other piece?
2 to 3.
And I know what you mean, and I know what you would do, and you would end up with the right answer, but as written, this is wrong. The integral from 2 to 3, as written, is that going to be a positive value when I evaluate? And for total area, I want it to be positive. So I have ways. Okay. So a heads up, AP often asks, set up, but do not evaluate. They're just like, it's irritating arithmetic, I don't want to bother you with it, but show me you know how to set it up. So that would be a setup. What's another alternative?
We do absolute value
Where?
of the whole integral from 2 to 3. Or both of them.
Like that?
Yeah.
Would it give me the same thing if I moved the bars inside?
No.
In this case, it would, like the bars inside or outside, because we are just doing, the way it was written, we're just doing that slice.
But like as a general practice, wouldn't you want them outside?
No.
No.
Like, okay. If they ask this question, super rockin' easy. There you go. Boom. Absolute value on the inside because it says, deal with the function first. If it ever went negative, the nerve. Flip it up and now find the area. But, okay, so in this case, the bars are okay on outside the whole thing or on the inside. They're gonna have the same effect. There are more options. Francesca, did you have a different one?
Evaluate from 3 to 2.
So adding from the other direction, because flipping the bounds changes things. So there are a whole bunch of options. And sometimes they have multiple choice questions that are, hey, all of these can be used to find the total area. Which one does not work? Huh. Okay. Or they'll say something like set up but do not evaluate. And you have choices. A whole bunch of things are okay. Go crazy, not too crazy. All right, so if they are asking you total area, I don't know that you need to write this down, but find where is the function positive and where does it start to go negative. Find all the places where it was negative and do a separate integration for that. Wrong thing. I'm not asking you to do it, but I want to process. How do we find that shaded area? Yep.
Could you differentiate towards the y-axis?
Okay. How would I differentiate?
Make like y a function of x, or wait, x a function of y, and then like rewrite it with like dy.
You want to integrate that? I mean, okay, interesting. First period mentioned that too, for which I'm like, interesting idea. You don't quite know how to do that as required yet. And gross, much too hard. other ideas?
Take, sounds more complicated, take integral of 0 to 1 and add 3 to it. Because that's
Okay.
the area, and then,
And 3 to it, why 3? Because that's this rectangle, so you're saying, how,
and then the second one, you take the integral and subtract it from 6. Or it from 3 again.
close, there's a mistake.
Absolutely.
Isn't it the same thing as integrating from y equals negative x squared plus 4?
It's a new one. Okay, for what you had said, I do want this area,
Total shift area, that's fine.
but it was below the x-axis, so integrating, I need to either do the opposite, like subtract the negative stuff that comes out. And Andy, okay. I was going for something easier than that. But yeah, that'll go. How about I leave it as it is, but just, I'm gonna integrate y equals x squared, but the height is 0 to 4. And I need to subtract it from the rectangle. Because this integral found the space that I want to cut off out of the rectangle. So this, lots of ways to think about it. And Andy, if you see it as flipping it upside down so you didn't have to do subtracting, but you really needed to understand, have command of understanding what the graphs are doing, it's scary, but not wrong. Cool? So all of these guys are different integrations of areas. Okay. What else did we do? Today's homework is back out of the textbook again. Did you guys have questions on anything from Delta Math that came up? Because it had some average value and it had some like,
On the AP test, do we have to simplify our answers?
no.
Yay.
Yeah, the AP test, kids leave this. And I'm like, you mean -5? Like, come on, people, square root of 1? 1, why? An exception, sometimes they get pissed off at that. Natural log of 1? 0. So they're okay with leaving square root of 1, but sometimes they get angry about, what, you don't know that the natural log of 1 is 0? Okay. All right, I don't want to get too far ahead of things. I will start the other fundamental theorem of calculus piece tomorrow, but you guys can start the homework, which is largely, the start of it is here. Sometimes I have it on the next page too, but no, I don't have it consolidated. So that's the start of it. Textbooks are behind column.